Chinese Lunar Exploration Program, CLEP. Chinese. Pinyin. Zhongguo Tanyu, also known as the Chang'e Project, Chinese. Pinyin. Chang'e Gongqiang, after the Chinese moon goddess Chang'e, is an ongoing series of robotic moon missions by the China National Space Administration, CNSA. The program incorporates lunar orbiters, landers, rovers and sample return spacecraft, launched using Long March rockets. Launches and flights are monitored by a telemetry, tracking, and command TT&C system, which uses 50-meter, 160-foot radio antennas in Beijing and 40-meter, 130-foot antennas in Kunming, Shanghai, and Urumqi to form a 3,000-kilometer, 1,900-mile VLBI antenna. A proprietary ground application system is responsible for downlink data reception. Ouyang Ziwan, a geologist, chemical cosmologist, and the program's chief scientist, was among the first to advocate the exploitation not only of known lunar reserves of metals such as titanium, but also of helium-3, an ideal fuel for future nuclear fusion power plants. Yi Peijian serves as the program's chief commander and chief designer. Scientist Sun Jiadong is the program's general designer and Sun Zezhou is deputy general designer. The leading program manager is Luan Ng. The first spacecraft of the program, the Chang'e 1 lunar orbiter, was launched from Xichang Satellite Launch Center on the 24th of October 2007, having been delayed from the initial planned date of the 17th to the 19th of April 2007. 5. A second orbiter, Chang'e 2, was launched on the 1st of October 2010. Chang'e 3, which includes a lander and rover, was launched on the 1st of December 2013 and successfully soft landed on the Moon on the 14th of December 2013. Chang'e 4, which includes a lander and rover, was launched on the 7th of December 2018 and landed on the 3rd of January 2019 on the South Pole Aitken Basin, on the far side of the Moon. A sample return mission, Chang'e 5, which launched on the 23rd of November 2020 and returned on the 16th of December in the same year, brought 1,731 grams, 61.1 ounces, of lunar samples back to Earth. As indicated by the official insignia, the shape of a calligraphic nascent lunar crescent with two human footprints at its center reminiscent of the Chinese character for moon. The ultimate objective of the program is to pave the way for a crewed mission to the Moon. China National Space Administration head Zhang Kejian announced that China is planning to build a scientific research station on the Moon's south pole, within the next 10 years, 2019-2029. The Chinese Lunar Exploration Program is divided into 4 main operational phases, with each mission serving as a technology demonstrator in preparation for future missions. International cooperation in the form of various payloads and a robotic station is invited by China. Phase 1. Orbital missions. The first phase entailed the launch of 2 lunar orbiters, and is now effectively complete. Chang'e 1, launched on the 24th of October 2007 aboard a Long March 3A rocket, scanned the entire Moon in unprecedented detail, generating a high-definition 3D map that would provide a reference for future soft landings. The probe also mapped the abundance and distribution of various chemical elements on the lunar surface as part of an evaluation of potentially useful resources. Chang'e 2, launched on the 1st of October 2010 aboard a Long March 3C rocket, reached the Moon in under 5 days, compared to 12 days for Chang'e 1, and mapped the Moon in even greater detail. It then left lunar orbit and headed for the Earth-Sun L2 Lagrangian point in order to test the TT&C network. Having done that, it completed a flyby of asteroid 4179 Tutatis on the 13th of December 2012, before heading into deep space to further test the TT&C network. Phase 2. Soft landers rovers. The second phase is ongoing, and incorporates spacecraft capable of soft landing on the Moon and deploying lunar rovers. Chang'e 3, launched on the 2nd of December 2013 aboard a Long March 3B rocket, landed on the Moon on the 14th of December 2013. It carried with it a 140 kilograms, 310 pounds, lunar rover named U2, which was designed to explore an area of 3 square kilometers, 1.2 square miles, during a 3-month mission. It was also supposed to conduct ultraviolet observations of galaxies, active galactic nuclei, variable stars, binaries, novae, quasars, and blazars, as well as the structure and dynamics of the Earth's plasmasphere. Chang'e 4 was launched on the 7th of December 2018. Originally scheduled for 2015, was a backup for Chang'e 3. However, As a result of the success of that mission, the configuration of Chang'e 4 was adjusted for the next mission. It landed on the 3rd of January 2019 on the South Pole Aitken Basin, on the far side of the Moon, and deployed the Yutu-2 rover. Phase 3. Sample Return Edit. The third phase included a lunar sample return mission. Chang'e 5T1 was launched on the 23rd of October 2014. It was designed to test the lunar return spacecraft. Chang'e 5 was launched on the 23rd of November 2020, landed near Mons Rumker on the Moon on the 1st of December 2020, and returned to Earth with 2 kilograms of lunar soil on the 16th of December 2020. Final phase. Lunar Robotic Research Station Edit. After the 3 steps phase is done, the phase for the development of an autonomous lunar research station near the Moon's south pole will commence. Chang'e 6, expected to launch in 2025, will investigate the topography, composition and subsurface structure of the South Pole Aitken Basin. The mission will return samples to Earth. Chang'e 7, expected to launch in 2026, is a mission that will explore the South Pole for resources. The mission will include an orbiter, a relay satellite, a lander, a mini flying probe, and the Rashid-2 rover provided by the United Arab Emirates. Chang'e 8, expected to launch in 2028, will verify in situ resource development and utilization technologies. It may include a lander, a rover, and a flying detector, as well as a 3D printing experiment using in situ resource utilization (ISRU) to build a structure. It will also transport a small sealed ecosystem experiment. It will test technology necessary to the construction of a lunar science base. Crewed mission phase. As of 2019, China was reviewing preliminary studies for a crewed lunar landing mission in the 2030s, and possibly building an outpost near the lunar South Pole with international cooperation. 2035. International Moon Base and Application. In 2021, China and Russia announced they will be building a moon base together, also formally invited more countries and international organizations to join their International Lunar Research Station (ILRS) project being developed by the two nations, as a competitor to the American Artemis program. Cooperation with Russia. In November 2017, China and Russia signed an agreement on cooperative lunar and deep space exploration. The agreement includes 6 sectors, covering lunar and deep space, joint spacecraft development, space electronics, Earth remote sensing data, and space debris monitoring. Russia may also look to develop closer ties with China in human spaceflight, and even shift its human spaceflight cooperation from the US to China and build a crewed lunar lander. Key technologies. Long-range TT&C. The biggest challenge in Phase 1 of the program was the operation of the TT&C system, because its transmission capability needed sufficient range to communicate with the probes in lunar orbit. 28 China's standard satellite telemetry had a range of 80,000 kilometers, 50,000 miles, but the distance between the Moon and the Earth can exceed 400,000 kilometers, 250,000 miles, when the Moon is at apogee. In addition, the Chang'e probes had to carry out many attitude maneuvers during their flights to the Moon and during operations in lunar orbit. The distance across China from east to west is 5,000 kilometers, 3,100 miles, 29, forming another challenge to TT&C continuity. At present, the combination of the TT&C system and the Chinese Astronomical Observation Network has met the needs of the Chang'e program, 30, but only by a small margin. Environmental adaptability. Edit. The complexity of the space environment encountered during the Chang'e missions imposed strict requirements for environmental adaptability and reliability of the probes and their instruments. The high radiation environment in Earth-Moon space required hardened electronics to prevent electromagnetic damage to spacecraft instruments. The extreme temperature range, from 130 degrees Celsius (266 degrees Fahrenheit) on the side of the spacecraft facing the Sun to -170 degrees Celsius (-274 degrees Fahrenheit) on the side facing away from the Sun, imposed strict requirements for temperature control in the design of the detectors. Orbit design and flight sequence control. Edit. Given the conditions of the three-body system of the Earth, Moon and a space probe, the orbit design of lunar orbiters is more complicated than that of Earth-orbiting satellites, which only deal with a two-body system. The Chang'e 1 and Chang'e 2 probes were first sent into highly elliptical Earth orbits. After separating from their launch vehicles, they entered an Earth-Moon transfer orbit through 3 accelerations in the phase-modulated orbit. These accelerations were conducted 16, 24, and 48 hours into the missions, during which several orbit adjustments and attitude maneuvers were carried out so as to ensure the probe's capture by lunar gravity. After operating in the Earth-Moon orbit for 4 to 5 days, each probe entered a lunar acquisition orbit. After entering their target orbits, conducting 3 braking maneuvers and experiencing 3 different orbit phases, Chang'e 1 and Chang'e 2 carried out their missions. Attitude control. Lunar orbiters have to remain properly oriented with respect to the Earth, Moon and Sun. All onboard detectors must be kept facing the lunar surface in order to complete their scientific missions. Communication antennas have to face the Earth in order to receive commands and transfer scientific data, and solar panels must be oriented toward the Sun in order to acquire power. During lunar orbit, the Earth, the Moon and the Sun also move, so attitude control is a complex 3-vector control process. The Chang'e satellites need to adjust their attitude very carefully to maintain an optimal angle towards all 3 bodies. Hazard avoidance. During the second phase of the program, in which the spacecraft were required to soft land on the lunar surface, it was necessary to devise a system of automatic hazard avoidance in order that the landers would not attempt to touch down on unsuitable terrain. Chang'e 3 utilized a computer vision system in which the data from a down-facing camera, as well as 2 ranging devices, were processed using specialized software. The software controlled the final stages of descent, adjusting the attitude of the spacecraft and the throttle of its main engine. The spacecraft hovered first at 100 meters, 330 feet, then at 30 meters, 98 feet, as it searched for a suitable spot to set down. The U-2 rover is also equipped with front-facing stereo cameras and hazard avoidance technology.
We hope you liked this video. To get more interesting videos, click the like button and subscribe. Share our channel Science Ponder. Thank you.